Have you ever stopped to think about how people did really big calculations before we all had calculators in our pockets? I mean, the complex math that literally built bridges and even helped send us to the stars. Well, for centuries, scientists and engineers had this amazing shortcut, a kind of secret code. And today, we're going to crack it. So let's just dive right in, shall we? Take a look at this thing. You've got multiplication with decimals, a cube root, and division, all rolled into one. I mean, trying to do this by hand would be an absolute nightmare of long multiplication and just frustrating guesswork. It looks like it would take forever to solve, right? But what if it didn't? You see, for hundreds of years, there was this unbelievably clever trick to turn a monster like this into, well, simple addition and subtraction. Now, it wasn't magic, but it was probably the next best thing. It was a whole mathematical language designed to make the complicated simple. So let's get right to it. Our first section, unlocking the logarithm. It is time to find the key that cracks this entire code wide open. Okay, so a logarithm, or log for short, is way simpler than it sounds. All it does is answer one simple question. What power? For instance, if we are using a base of 10, the log of 100 is just asking, what power do I need to raise 10 to in order to get 100? And the answer, of course, is 2. That's it. And this really shows you how logs are just the flip side of powers or indices, which you are probably familiar with. You know that 10 squared equals 100. Well, in log form, we just write that as log base 10 of 100 equals 2. Same for the next one. 10 cubed is 1000, so the log of 1000 is 3. It's the exact same relationship, just looked at from a different angle, focusing on the power itself. So, if you remember one thing, make it this. A logarithm is basically an undo button for a power. It's a tool that was specifically designed to hunt down that hidden exponent. And as we're about to see, that is an incredibly powerful thing to be able to do. Which brings us perfectly to our second section, the 3 magic rules. This right here is where logarithms get their real superpowers. These rules are the toolkit that transforms nasty-looking math into easy-peasy arithmetic. Just look at this. This is the heart and soul of the whole system. And it works because of the laws of powers you already know. Remember how when you multiply powers with the same base, you just add the exponents? Well, that's exactly why we can add their logs. The same logic holds true for division and powers. This is a total game changer. And this is the entire point. Logarithms were literally invented to replace the most tedious, most error-prone calculations with something much simpler, like addition and subtraction. They are designed to turn complexity straight into simplicity. Alright, enough theory. Let's move on to our third section and actually see this in action. We are putting logs to work. We're going to take that beast of a problem from the beginning and solve it step by step. And here it is again, our original problem. It looks just as intimidating as it did a few minutes ago, but the difference is now we have the secret code to take it apart. First things first, we have to translate each of our numbers into the log world. For centuries, people did this using a big reference book called the log table. So we just look up our numbers. The log of 85.2 is 1.9304. The log of 49.7 is 1.6964. And the log of 2.58 is 0.4116. Okay, our problem is now officially translated. And now for the magic. We're going to apply all 3 rules at once. That multiplication on top, that becomes addition. The cube root of 49.7, that's the same as a power of 1/3, so it becomes 1/3 times its log. And the division by 2.58, easy. That just becomes subtraction. We've turned that whole complicated mess into one simple line of arithmetic. So we just do that simple math, 1.9304 plus 1/3 of 1.6964, and then subtract 0.4116, and that gives us 2.0843. And believe it or not, the hard part is completely over. That one simple calculation did all the heavy lifting for us. So, our answer is still in that secret log code. To get the final result, we have to translate it back. And this process is called finding the antilogarithm. You know, if a log asks what power, the antilog is basically asking, okay, what's the actual result of that power? It's the same process, just in reverse. And when we look up the antilog of 2.0843, we get approximately 121.4. And if you were to put that original monster of a problem into a modern calculator, the answer you'd get is 121.42. That is astonishingly accurate, and we did it all by trading in multiplication, division, and roots for some simple arithmetic. How cool is that? Now that you have seen the power of the code for yourself, it's time for you to give it a try. Welcome to our final section, your final challenge. Your mission, should you choose to accept it, is to find the square root of 789.5 using logs. Now, think back to our magic rules. Which one helps us out with roots? Here's a hint. A square root is exactly the same as raising something to the power of 1/2. And that's really the big takeaway here. Logarithms show us that math isn't just about grinding out numbers. It's about creativity. It's about finding those clever shortcuts and seeing the hidden connections that turn a really complex problem into an elegant solution. It's a beautiful way of thinking that's just as powerful today as it was 400 years ago.